Completing 3D successfully, now we are going to come to 2D problems. So what happens in real world? Everything is 3D. There is no such thing as 2D bodies. So what happens is some problems can be simplified and then they can be simulated in the 2D space rather than the 3D space. For example, there are some problems like pressure vessel where the vessel is symmetric around an axis, and then the loading is also symmetric around an axis. That can be considered as an axisymmetric problem. Then other types of problems in 2D are the plane stress problems where the load will be applied in the in-plane direction as well as the stresses inside the body occur in the same in-plane direction. So likewise you also have the plane strain considerations in 2D. Then reducing the problem to 2D, it has many advantages. Say for example, we can build a simpler geometry, we can build better mesh quality, we have less time, we will require less computational time, it is easy to display and analyze results, and also in sometimes if you don't take any other assumptions, then we get more accurate results when compared to the 3D one. So what happens, in short, we can say that the 2D simulation models will help us to handle this particular simulations much better. So coming to this particular problem, here we have a rack as well as a gear. So what we are going to do is we are going to take this as a plane stress problem and we are going to solve this particular problem. So here the main aim of the problem is we are designing a press that should be capable of delivering 2500 newtons of force at this particular position of the rack. So what happens, in order to design this particular mechanism, we are going to apply the load here and we are going to fix this particular gear and we are going to find out how much momentum is required to be applied here so that the force at this particular point of the rack will be around 2500 newtons. That is the first case. And coming to the second case, what we are going to do is, instead of giving the force here, we will fix this particular position and then we are going to apply some momentum value and try to find out what is the force value that is being generated for the moment value that has been applied here. We are going to perform all of these things in ANSYS Workbench and we are going to simplify this geometry and we are going to perform the analysis in 2 dimensions. Thank you. Perform analysis on the gear and rack, I have opened ANSYS Workbench. So once I open the ANSYS Workbench, I am going to go to the analysis toolbox. In analysis toolbox, I am going to select the static structural, drag it and drop it on the project schematic. And once I have done that, I can just give out the engineering material. But here, according to the problem specification, both the gear and the rack are prepared with structural steel. So by default in ANSYS Workbench, the structural steel is defined, so we need not change the material or enter any new material. So now what I am going to do is, before you go and import the geometry, you need to right click on the geometry cell and you need to select this particular properties option. So what happens if you select this properties option, number of options will be appearing here. So here these particular cell are the options which will be useful to import the type of geometry. That is, for example, if I am importing a geometry, whether I need to import the solid bodies or surface bodies, line bodies, I can dictate from here. So then there is another option which we need to change, which is nothing but the analysis option. So in the analysis option, as you are going to perform a 2D analysis, you need to change this from 3D to 2D. So here is the analysis type option. So you need to change it from 3D to 2D. Likewise, if you click on any other cell, you are going to get those corresponding properties here and you can change it. There are no much options to change, but this is pretty useful. So once I have changed this analysis type from 3D to 2D, then only you need to import your geometry. Otherwise, once you have imported the geometry, it is not possible to change the analysis type. So I am going to right click and say import geometry, and I am going to select this gear set 2D. And once I have selected it, I am right now going to double click on the model cell in order to open the mechanical, ANSYS mechanical, and then apply the required boundary conditions and try to solve this particular problem. So see, once this particular problem has been loaded into ANSYS mechanical, the first and foremost thing you need to do is you need to go to the geometry branch, and in the geometry branch there will be term known as a 2D behavior or an option known as a 2D behavior. In this you need to set its behavior. Here the behavior is plane stress, so we need not change any option. But for example, if we are going to perform a axisymmetric 2D analysis, we need to change the 2D behavior from plane stress to axisymmetric. Likewise, if you are doing something like plane strain, you can just go and select this plane strain from here. So once you have set this to plane stress, now what you need to do is you need to edit the width of this or edit the thickness of this particular objects. So in order to edit the thickness of the objects, surface objects, you need to expand this geometry tab or group. I am going to just click on gear, and here the thickness was assumed to be 1000 mm, but according to the problem it is only 12 mm, so I am going to just type in 12 mm and I am going to change the thickness of this gear. Now I am going to select the rack, and then in the rack also I am going to give the thickness to 12. So once I have given the thickness, now what I need to do is I need to create a remote point based upon which I can apply boundary conditions. So in order to create a remote point, you need to select the model branch, and in the model branch you will have an option called as the remote point. So I am going to select this remote point, and once I have selected this particular remote point, it will ask me the geometry, at which geometry I selected there will be a remote point created. So I am going to go and select this inner circle and then press apply. Here the flag is showing the position of the remote point. Why I have selected remote point? Because here we are going to apply the remote displacement. So what is the difference between normal displacement as well as remote displacement? What happens is, in remote displacement we will get access to rotational degrees of freedom as well. Here we need to fix the rotation degree of freedom so that the gear is going to remain still. So for that purpose I have created a remote point. Okay, then coming to connections, we need to change, as I told you that by default, say the behavior of the contacts here bonded, but we need to change it to from bonded to no separation. So once I have selected this no separation, now what I am going to do is I am just going to right click and say mesh. So once the meshing is done, then we are going to apply the boundary conditions, then we are going to calculate the required results. We are going to do all of these things in the next lecture. We have generated the required mesh. Now what we need to do is we need to apply the boundary conditions. So in order to apply the boundary conditions, I am going to right click on the static structural, say insert, and I am going to go to remote displacement. And once I select the remote displacement, there are different scoping methods. From the scoping method, I am going to select, instead of geometric selection, I am going to select the remote point option, and there is only one remote point which I have created. So in the remote points I can select only that particular point. I just click on the drop down arrow and I am going to select the same point which I have created earlier. So once I have done this, here it is asking me what are the components that are free and what are the components that are fixed. So here I am going to fix every component so that the gear cannot translate, the gear cannot rotate. So once we have constrained all the required dimensions, now what I need to do is I need to provide a boundary condition for this particular rack so that it can slide up and down. So for that purpose, what I am going to do is I am going to say insert, and I am going to select the frictionless support, and I am going to select this particular edge, and I am going to apply the frictionless support. So what happens when I apply the frictionless support, this particular rack will not be moving in this direction, it can only move in this particular direction. So once I have done this thing, I need to apply the force. So for that purpose, I am going to right click on the static structural, say insert, and I am going to apply force. So once I select the force, I am going to select this particular edge and I am going to apply the force. So instead of the vector, I am going to change it to components, and in the components I am going to give 2500 newtons, because according to the problem that is the force which has to be generated by this particular rack. So I have given 2500 newtons, and then I am going to solve. So I am going to right click and say solve. So once you have solved the problem, now what we need to do is we need to ask, or we need to view the results. For that purpose, what I am going to do is I am going to right click on the solution, say insert, and then I am going to see the total deformation, and I am going to right click, say evaluate all results. Now I am going to just see animate this particular results. In order to stop the animation, you can click here. In order to go forward to the next frame, you can click here. You can if you want to go to the previous frame, you can click here. You can set the speed of this particular animation through this settings. So here see, it is the rack is moving up and down in this particular fashion. This is because of the frictionless support that which I have provided to this edge. So then I am going to just stop the animation. Now what I need to do is I need to find out how much momentum has to be applied at this particular say at this particular surface to get a force of 2500 newtons at this face. For that purpose, what I am going to do is I am going to go to the solution. I am going to say insert. In the insert, I am going to go to the probe tool. In the probe tool, I am going to say I want momentum. So I want to select the moment reaction. And now once we have selected the moment reaction, we need to specify at which boundary condition we want this momentum to be calculated. So what happens, this is the surface, or this is the boundary conditions where we want the momentum to be calculated. That is why I am going to select this particular support, which is nothing but the remote displacement support. So I have selected this remote displacement support, and once I am satisfied with that, I am going to right click and say evaluate all results. So once I press evaluate all results, then you can see if I click on this moment reaction and just scroll down in the details window, then you can clearly see the value of momentum is 92,099 Newton mm. So our stated goal was to determine the required momentum that must be applied to the gear in order to produce a 2500 Newton force in the rack. And here from the computer we were able to calculate the required momentum to be 92,099 Newton mm. So the total approximate moment torque that is required was around 92,100 Newton mm. So now in the next case, what we are going to do is, instead of applying force here, we are going to apply this amount of torque here and then find out what is the force that is going to be generated at this particular face of the rack. Thank you. In this lecture, what we are going to do is, instead of applying force and finding out momentum as in the earlier case, we are going to apply the momentum here and try to find out the force generated. For that purpose, I can just right click on this, or click on the drop down arrow here, and I can say duplicate. So if I say duplicate, what happens? The geometry, engineering data, everything, the whole analysis system will be duplicated as a new one. In that we can change a little settings, and then we can perform the new analysis instead of taking the static structural and bringing it into project schematic again and then recreating and every step of this particular process. We can directly go and use this particular duplicate option. So once the analysis system has been duplicated, I am going to double click on the model so that it is going to open the ANSYS mechanical for this B analysis system. See here. So the first analysis system you have dragged into the computer will be denoted by A, and the next analysis system which you are going to drag is going to be represented B. Likewise, it is going to be represented in the alphabetical order here. So once I can just double click on the model cell so that it maximizes again. So after opening this ANSYS mechanical once again, so here we need to change some boundary conditions before we recalculate the total problem. So the first condition is you need to select this remote displacement, and here you need to free up this rotation, because what happens when we apply a momentum here, what happens, this is going to turn, and this turn should be able to create force on this rack. For that purpose, I'm going to free up this particular rotation. So I have freed up this particular rotation about Z. Then coming to this particular rack, we need to fix this particular surface. So right click, sorry, it is a line. So I'm going to right click, say insert, then go to fixed support, and I'm going to select this particular line, this particular edge, and I'm going to press apply. Now we need to delete this force also. So I right click on this force and say delete. So these are the boundary conditions which are needed in order to analyze how much of force is being generated here for the applied amount of torque or momentum. So the next thing you need to do is you need to right click, say insert, and you need to go for the moment. So once you go for the moment, it will ask for the geometry. You can just click here, or otherwise in the scoping method you can just select the remote point, and from the remote point you select the remote point and you apply 92,100 Newton mm of torque. Then once you have applied this one, I'm going to delete this moment reaction here, and then I'm going to add a force reaction instead of a momentum reaction. I'm going to add a force reaction. Say insert, so go to probe. In the probe you need to select this force reaction instead of moment reaction, and once you have done this, you need to give at which boundary condition you want to find out the force reaction. We want to find out the force reaction at this particular edge, so I am going to select the fixed support boundary condition. So once I have done setting up the analysis, I am going to right click and say solve. So once I solve this particular problem, I am going to check the force reaction probe and the value that occurred at the force reaction probe. So once the analysis is done, I am going to just click here, say the force reaction was we got a force reaction of 23. See here, this is the total force reaction, that is 2373.4. so this was the force that was generated if we are going to apply a momentum of some 92,100 Newton mm. So this is how you can find out the reactions as well as the moments using particular probes at different boundary conditions. In the next lecture, we are going to see how we can simulate a simple nut and bolt system by taking into consideration the axis symmetry present inside the particular system. We are going to solve that problem in 2D as well inside ANSYS Workbench. Thank you. Here in this particular lecture, we are going to see how to perform axis symmetric analysis of a bolt and nut assembly. See here, there is a bolt, nut as well as plate assembly present here, and this particular bolt is made up of the steel as well as nut is also made up of steel. So this particular bolt is loaded with 10 kilonewtons of bolt pre-tension. Our aim is to find out the stresses that are developed inside these threads present on the bolt as well as the nut by performing analysis in ANSYS Workbench. We are going to use the axis symmetric nature that is present inside this particular geometry in order to simplify our analysis. Thank you. To perform analysis on a bolt and nut, that to axis symmetric analysis on a bolt and nut, what I am going to do is I am going to take the static structural analysis system, drag it and drop it on the project schematic. And I need not change the material, as the default material is structural steel, and that is the particular material with which the bolt and nut has been manufactured. So now I am going to geometric cell and I am going to change the analysis type to from 3D to 2D. Remember, if you are going to perform any analysis in 2D, you need to change this particular option here, and this particular analysis option should be changed before you just import the geometry. Once you have imported the geometry, you will not be able to change this particular option. And here there are other lot of options that are useful to import this particular geometry. So for example, if I am importing a geometry, in that particular geometry there are number of types of bodies, say solid bodies, surface bodies as well as line bodies. Then I can ask this particular software to import only one kind of body. It may be a solid body, it may be a surface body, or it may be a line body. or otherwise I may ask the software to say import every kind of particular available bodies inside the imported geometry. And here there is something known as the parameter keys and attributes. So parameters means in the CAD software which we are designing, if we give the dimensions, we can import those dimensions with names to this particular software. So once I have changed this analysis system type to 2D, then I am going to just right click on the geometry cell, say import geometry, and then browse, and I am going to select the bolt and nut STP, and I am going to press open. And once I have imported the geometry, I am going to double click on the model cell. So right now what I am going to do is, once the ANSYS mechanical is going to open, I am going to set up the boundary conditions as well as mesh, and I will try to solve the particular problem. Now what happens, once the geometry gets loaded into the static structural, I am going to geometry branch, and see here the 2D behavior is by default, as I told you, it will be in plane stress. But if I solve this particular problem in plane stress, it will not yield me good results. So what I need to do is, I need to change the behavior from plane stress to axis symmetric. So once I change this to axis symmetric, it is fine now. Now what I need to do is, I need to create the connections between the bolt as well as the nut surfaces. So here you see, as I have told you earlier, when you are going to import an assembly, even it may be a 3D assembly or a 2D assembly, our ANSYS Workbench is going to create some contacts. See here, it has created some contacts. But what happens in real world, the two surfaces will not be in contact. Only one surface will be in contact. So for example, if the bolt is pre-tensioned, what happens, this bottom surface of this particular bolt will be in contact with the top surface of this particular thread from the nut. So what I need to do is, I need to manually select or change the contacts. For that purpose, what I am going to do is, first of all I am going to select the contact edges which are represented in red in color, and these edges are present on this particular bolt body. Here you can see the preview, and from the preview you can tell this surfaces contact bodies are present on this bolt. So what I am going to do is, first of all I am going to right click on this nut body, and then I am going to hide the body so that I have a good view of these threads that are present on the bolt. And now what I am going to do is, instead of selecting all of these things, I am going to go to the contact here, and then I am going to select only this bottom edges. So I am going to select this bottom edge, and by pressing Ctrl I am going to select the other bottom edges, and I need to select about 8 edges like this. So I need to select somewhere around 8 edges. I think it is enough. 1, 2, 3, 4, 5, 6, 7 and 8. So now I can apply. So once I have pressed apply, see only the bottom edges are selected. Bottom edges of this particular threads present on the bolt are selected. Now what I am going to do is, I am just going to right click and say show all bodies. Right now I am going to select this particular bolt body, and then I am going to just hide this particular body. And now what I am going to do is, I will go back to the edges, and then I am going to select the top edge of this particular threads on the nut. I am going to select only the top faces. See here, I am going to select only top faces, and here also I am going to select 8 edges. And once I have selected that one, I can say apply, and now I can right click and say show all bodies. So once I have done this thing, I need to change the contact type. As usual, by default the contact type will be bonded. I need to change it to frictional contact, because there will be friction between these two. And once you select the frictional contact, you should be providing a friction coefficient value of mu. So I'm going to specify it as a 0.3. So once I have set up the required contacts, the next step is to set up all the required boundary conditions and the loads to solve this particular problem, which we are going to do in the next lecture. In the previous lecture, when we had changed this particular contacts, I had to change this particular say formulation from program control to augmented Lagrange. So why we have selected that particular formulation? Because by practice this particular formulation holds good for solving frictional contacts. So that is why I have selected that manually instead of leaving that particular option to the software. And now after finishing this, we are going to generate the mesh. So, and we are going to generate the mesh and see if the mesh is good or not, and if it is not good, then we are going to try to use some localized controls. But here see, with the automated mesh itself, this particular software has refined our mesh at this particular edge, so we need not say further refine the particular mesh. Now what I am going to do is I am going to just right click and say insert, and then I am going to go say I am going to select the frictionless support, and I am going to apply the frictionless support to this particular edge and to this particular edge as well, and I am going to say apply. And once I have applied this frictionless support, then I need to apply the force. So for that purpose, what I am going to do is I am going to right click on the static structural, say insert, and in the insert I am going to select this particular force. So once I select this particular force, I am going to select this particular edge and I am going to apply, and I am going to, instead of going for vector, I am going to select the component system. In the component system I am going to give it my 10,000 minus 10,000 newtons. So because it was given 10 kilonewtons of tension, pre-tension, so I am going to give some 10,000 newtons. So once I have entered that particular value, see, it is going to drag it like this towards the downside. So now what I need to do is I have given all the required boundary conditions, contacts and other forces. Now I need to solve the problem. So for that purpose, what I am going to do is I am going to just right click and say solve the problem. So while solving the problem, I will tell you one thing that so we have applied a load. See here, no problem, it's not a big problem here. So once you have applied the load of 10,000 newtons on this particular line, what happens is the software is going to divide this particular value by the area, and then it is going to take up the pressure value. For example, here this particular radius is 20 mm. So what happens, the total area of the circle here will be pi by 4 into 20 square. 10,000 divided by this particular value will be giving 31.83 MPa. So if you have taken this particular body in 3D, you would have selected the bottom face, and once you have selected the bottom face, you would have applied a pressure load of 31.83 MPa instead of the 10,000 newtons of force. So if you have a pressure value and you need to convert into line pressure value, what you need to do is you just multiply this particular pressure value into the area on which you want to apply, and that value which is going to yield is the value which you are going to apply as a line pressure instead of a area pressure. Then once we have done all these things, we are going to right click and say insert and say deformation, and I am going to say total deformation, and I am going to evaluate the results. So once I evaluate the results, I can just animate the results here. So see, it is trying to move downwards due to the force, and it is applying some pressure through this particular contact surfaces to the bolt as well, sorry, to the nut as well. Then you can also find out the stresses like radial stresses, axial stresses and other sorts of stresses here. You just need to right click, say insert, go to the stresses and then select the normal stresses, and then you give the orientation to x-axis, which is nothing but in the radial direction. So you will just rename it as radial stresses, radial stress. Then coming to other type of stress, which is stress, say insert, then go to the stress, then select normal stress, and then instead of the orientation to x-axis, you can change the orientation to y-axis, because this y-axis is going to coincide with this particular axis of this bolt or nut. So I am going to rename it by pressing F2 as axial stress. Then if you want to find out the circumferential stresses, you don't have the z direction in 2D, so you need not say define a circular coordinate system here. You just need to right click, say insert, then you can say normal stresses, select the normal stresses, and in the normal stresses you just rename it as hoop, and then you change the axis to Z, and then you just right click and say evaluate all results, so that you can find out the values, radial stress values, axial stress values, as well as the hoop stress values. So this is how we can perform an axisymmetric analysis on a bolt and nut. This is not only limited to bolt and nut. If you see any cases where there is axis symmetry, you can just remodel that 3D problem into a 2D problem, and you can solve it like this. So in the next lecture we are going to see how we can say take a 3D object, then convert it into 2D object, and then perform analysis on it. Thank you. Particular problem, we are going to take a bookshelf, and this simple model of a bookshelf, and this is prepared with a material of Young's modulus 13.1 GPa and a Poisson's ratio of 0.29, and we assume a load of 0.5 MPa was applied on the top surface, and see, we assume that this particular bookshelf is placed on the ground. So we need to find the stresses and deformation, and the purpose of this particular tutorial is to demonstrate the process of reducing the problem from 3D to 2D using the mid-plane option for such type of planar surface objects. Thank you. To perform analysis on the bookshelf, I have opened ANSYS Workbench. I am going to drag static structural onto this particular project schematic, and I am going to double click on engineering data. Here I need to add new material. I didn't have the name of the material, so I am going to give my own name for the material, say Rakesh, and once I have entered this particular material, I can go to linear elasticity, and I can drag this isotropic elasticity onto this material, and then I am going to enter the value. As per the problem specification, our Young's modulus was 13.1 GPa, which means I can convert the GPa into pascals by multiplying it into 10 to the power of 9. So my value will be 13.1 E9. Then coming to the Poisson's ratio, our value is 0.29. So once I have given this property values, I am going to close this engineering data manager. And now what I am going to do is I am going to select the geometry, and then I am going to just right click on the geometry, say import geometry, and I can browse and I am going to select this bookshelf option. Once I have imported the geometry into the design modeler, I am going to just right click on the geometry cell, and I am going to ask to edit the geometry, because what the geometry I have taken is in 3D and I should be converting it into 2D. As I have told you, in this tutorial we are going to use the option known as the mid-plane option to reduce or to convert this 3D to 2D. So once I have opened design modeler, it asks me to regenerate this particular geometry. So I am going to right click here and say generate, and once I generate, this particular object has been successfully imported into design modeler. Now what I am going to do is, first of all, I am going to set my units to millimeters. So it is not necessary at this particular point, but it is always good to check the units first. Then I am going to just go to view, and I am going to just switch off the frozen body transparency. So this is the solid body. Now I need to convert it into say 2D body or surface body. Then for that purpose, what I am going to do is I am going to go to the tools, and in the tools I am going to select the mid surface option. And as I have showed you before in the design modeler tutorial section, how to select the different face space so that a midplane will be created at the exact middle of these two planar faces. So see here, see, I am going to select this face, and by pressing Ctrl I am going to select this face. Then once again I am going to select this face, and I am going to select this face, and then coming to this I am going to select this face as well as this face, and then I am going to select this face as well as this face. So here I need to select planar faces in pairs, then only the midplane option will be able to generate and create a surface. So I am going to just select this surface, and I am going to select this surface. Once again I am going to select this surface, and I am going to select this surface, and then I am going to select this surface, and once again I am going to select this surface, and see, I am going to select this surface, and this surface. And remember, we need to select all the surfaces by pressing down the control button. So without that you won't be able to select multiple options. So I have finished applying. So a total of 11 face pairs were detected by the computer, and once I have done this thing, I am going to just right click say generate, so that the total body or the solid body will be converted into a 2D surface body. And remember, this particular option holds good for the bodies where there are lot of planar faces. You can use it even for circular faces, but it holds more good. It is more applicable to the objects which have planar faces. So once we have converted this into 2D, what we can do is we can just close this design modeler and then just open ANSYS mechanical. So I am going to double click on the model, and this opens my ANSYS mechanical. So once I open this particular mechanical one, now what I need to do is I need to fix the bottom surface. So for that purpose, I am going to select insert, say fixed support, sorry. Okay, no problem, we can even select the displacement and constrain all these particular motion. So I am going to select these two surfaces, and I am going to apply and say 0, enter 0 here, enter 0 here, and enter 0 here, so that this particular displacement constraints will be acting as a fixed constraint. Then coming to the loads, I am going to right click on the static structure, say insert, and I am going to select insert, and I am going to select this surface as well as this surface and apply. Now going to enter a value of 0.5 MPa as specified in our problem. So once I have done this particular applied this particular pressure value, I am going to right click and say solve, and once I solve, I am going to get the equivalent stresses as well as this particular say deformations and other sorts of things. So it is saying there is a large deformation, you need not worry, because what happens is our computer has detected due to the applied load there was a very excessive deformation that has occurred inside the body. We'll see what is happening. So I'm going to insert say deformation, and I'm going to say total deformation, and I'm going to just evaluate the results, and see here there was a deformation of 504 mm. That means even though the software is not able to represent the breakage, but in real case what happens, if we get 504 mm for this particular structure, it has failed far before itself. So one thing you need to do is you need to redesign the total structure, or otherwise what you need to do is you need to just reduce the amount of load. So for example, if I reduce the load by 10 times 0.05, and I am going to right click, say I am going to just solve the problem once again, and then see the deformation, total deformation was around 50 mm. Even though if the deformation was around 50 mm, no possibility that this design is going to work to bear such amount of load. So we need to redesign the total system. So this is how we can use the options present inside ANSYS Workbench to convert a 3D problem into a surface problem and then perform the analysis. Once we have done this particular analysis, we are going to close this one, and we are going to save this particular project file. In the next section, you are going to see how you can use ANSYS Workbench in order to perform analysis on 1D problems or different structural problems, say like beams, and how to draw SFD BMD diagrams using ANSYS Workbench. Thank you.